This is AP Calculus Practice Exam 1. In Part 1, we will work on multiple choice questions for which a calculator is not allowed. Number 1. If y equals x sine x, then dy dx equals what? So we are just going to take the derivative using the product rule, which says the first time through, we take the derivative of the first factor, and the derivative of x is 1, and we multiply that by the second factor, which is left alone, so times sine x. Then we put a plus and we go through again. The second time through, we leave the first factor alone, so we just write x, and we take the derivative of the second factor. The derivative of sine is cosine. So the answer to number 1 is B. Number 2, let f be the function given by f of x equals 300x minus x cubed. On which of the following intervals is the function f increasing? We know that f will be increasing when f prime is positive. So our strategy will be to make a sign chart of f prime and see where it's positive. The derivative of 300x is 300. And for the next term, the 3 comes to the front, and we have 3x squared. If we factor out a GCF of 3, we have 3 times 100 minus x squared. But then we notice that we have the difference of 2 squares. So here is f prime in factored form. For the sign chart, we need to consider where f prime is equal to 0. Setting each of these factors equal to 0, we have x is equal to negative 10, and x is equal to positive 10. So these are the values that we will put on the sign chart. So here we have the negative 10 and the positive 10 on the number line, and I have a row for each factor, except for the positive 3. A positive constant does not affect the outcome of the sign chart, so I'm leaving that off. If this were a negative 3, I would have another row for the negative 3. Anyway, now we need to decide if these factors are positive or negative in each interval. X plus 10 is equal to 0 when x is equal to negative 10. So this is the cutoff. For values of x less than negative 10, this factor is negative. For values of x greater than negative 10, this factor is positive. 10 minus x equals 0 when x is equal to positive 10. So this is the cutoff. When values of x are less than 10, this factor is positive. For example, if x is 0, then you just have positive 10. For values of x that are greater than 10, this factor is negative. What about the overall sign of f prime? In the first interval, we have a negative times a positive, so that is a negative. A positive times a positive is a positive, and a positive times a negative is a negative. We are being asked where function f is increasing. That will only happen when f prime is positive, and that happens on this interval between negative 10 and positive 10. So the answer is B. Number 3, what is the integral of secant x tangent x dx? One way of integrating secant x tangent x is to ask yourself the derivative of what is equal to secant x tangent x. And the answer is secant x. So that's why the answer is A. Number 4, if f of x is equal to 7x minus 3 plus natural log x, then f prime at 1 is equal to what? Let's start by finding an expression for f prime of x. So the derivative of 7x is 7. The derivative of negative 3 is 0, so I write nothing. And the derivative of natural log x is 1 over x. So this is f prime. How about f prime at 1? That will be 7 plus 1 over 1, which of course is 7 plus 1, which is 8. So the answer is E. The graph of function f is shown above. Which of the following statements is false? Statement A says the limit as x approaches 2 exists. So for the limit to exist, the value of the function has to approach the same thing from the left and from the right. From the left side, as we approach an x value of 2, the value of the function is approaching a y value of 2. From the right-hand side, the function is approaching the exact same value. So the limit does exist, so this one is true. Statement B says the limit as x approaches 3 exists. Well, here is an x value of 3. As we approach 3 from the left, the function approaches a value of 5. As we approach 3 from the right, again, the function approaches a value of 5. So this limit does exist and the statement is true. Statement C says the limit as x approaches 4 exists. Well, here is an x value of 4. For the limit to exist, the function must approach the same value from the left and from the right. However, as we approach 4 from the left, the function approaches a value of, well, something less than 2. As we approach 4 from the right, f approaches a value of 4. So we are not approaching the same value on the left and on the right, so this limit does not exist, and this statement is false. We were looking for the false statement, so the answer is C. A particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance traveled by the particle from time t equals 0 to t equals 3? So we are given this function for the velocity as a function of time, and we are asked to find the total distance traveled. Well, the total distance traveled from 0 to 3 is the integral from 0 to 3 of the absolute value of velocity. For integrating the absolute value of something, I find it easiest to look at the graph. What does the graph of v of t look like? I can tell by the t squared that this is some type of a parabola. The fact that the squared term is negative means it is an upside down parabola of some type. Let's add a little bit more precision to it by finding the x-intercepts. Factoring gives us t times 6 minus t. So the velocity function will equal 0 at t equals 0 and t equals 6. These are the x-intercepts. So here is a rough sketch of the velocity curve. Notice that the velocity is positive between 0 and 6. So between 0 and 3, the absolute value of velocity will be the same thing as just the velocity. So in this case, the total distance will be given by the integral of velocity from 0 to 3. So the integral of 6t minus t squared dt. The antiderivative of 6t will give us t squared, then we divide by the new exponent, which gives us a 3. Similarly, the next term will be 1/3 t cubed. We need to apply the limits of integration from 0 to 3. This means we need to find the value at 3 minus the value at 0. Noticing that both terms have a t, the value at 0 will just be 0. Simplifying, we get 27 minus 9, which is 18. So the answer is D. For number 7, we need to find the derivative of this expression using the chain rule. So first, we take the derivative of the outer function. So we move the 5 out in the front, and we decrease the power by 1. We leave the stuff on the inside the same, so x to the 3rd power minus cosine x. However, next we multiply by the derivative of this inner function. So the derivative of x to the 3rd power is 3x squared. The derivative of cosine is negative sine. So the negative we'll switch the existing negative sign to a plus sign. And that's it. So the answer is E. A tank contains 50 liters of oil at time t equals 4 hours. Oil is being pumped into the tank at a rate of R of t, where R of t is measured in liters per hour and t is measured in hours. Selected values of R of t are given in the table above. Using a right Riemann sum with 3 subintervals and data from the table, what is the approximation of the number of liters of oil that are in the tank at time t equals 15 hours? Here is our strategy. The end amount at time t equals 15 should equal the initial amount at t equals 4 plus the change in amount from t equals 4 to t equals 15. We are told that there are 50 liters of oil at time t equals 4, so that is the initial amount. We know that the integral of a rate gives the change in amount. So the integral of R of t from 4 to 15 will be the change in the amount of oil between t equals 4 and t equals 15. We can use a right Riemann sum to approximate the value of this integral. When we do a Riemann sum, we are using rectangles to approximate the area under a curve. When we do a right Riemann sum, we draw our rectangles so that the right edge of the rectangle touches the curve. So right here. Our first interval goes from 4 to 7. So let's put 4 and 7 right here. We need to find the area of this rectangle, and we know the area of a rectangle is base times height. Well, the base is just going to be the width of this interval. From 4 to 7, the width is 3. What about the height of this rectangle? The height will be the value of the curve on the right-hand side of this rectangle. In other words, what is the value of R of t at 7? Well, that is 6.2. So 6.2 is the height of this rectangle. Our next interval goes from 7 to 12. So here you see 7 and 12. We need the base and the height of this rectangle. The base will be 5. That's 12 minus 7. And the height will be the value of R of t at 12, the right-hand side of this rectangle. And that is 5.9. The last interval is from 12 to 15. So the base of this rectangle is 3. And the height of the rectangle will be the value of R of t at 15. And that is 5.6. When you do each of these products, you get this. And when you do the addition, you get 114.9. So the answer is C. Let f be the function defined above. For what value of k is f continuous at x equals 2? Let's take a look at the definition of continuity. How do you show that f is continuous at c using the definition of continuity? You show that the limit as x approaches c from the right equals the limit as x approaches c from the left, which equals the value of the function at c. So if f is to be continuous at x equals 2, then the limit as x approaches 2 from the left must equal the limit as x approaches 2 from the right, which must equal the value of the function at 2. Notice also that we have the same factor in the numerator and the denominator. So we should be able to cancel these out without changing any of these limits. So let's imagine that these are now gone. When we think of the limit as x approaches 2 from the left, will we use the bottom piece, which is k, or will we use the top piece, which is 2x plus 1? Well, we are to use the top piece for all values except for x equals 2 itself. So if we are approaching 2 from the left, we are going to use the top piece. If we are approaching 2 from the right, we are going to use the top piece, because we won't be at x equals 2 if we were coming in from the left or from the right. So for this first piece of this triple equation, I'm going to use 2x plus 1 for f of x. So I have the limit as x approaches 2 from the left of 2x plus 1. But then, as I said, the limit as x approaches 2 from the right will also use 2x plus 1. So obviously these are going to be exactly the same thing. But let's talk about the value of the function at 2. At x equals 2, the value of the function is k. So we can just go ahead and put k right here. Both of these limits can be evaluated by direct substitution. If I substitute 2 in for x, we get 2 times 2 plus 1. And this is just the exact same thing, 2 times 2 plus 1. And whatever that is should equal k. Obviously, both of these have a value of 5. So that means k must equal 5. And the answer is E. What is the area of the region in the first quadrant bounded by the graph of y equals e to the x over 2 and the line x equals 2? Here's the vertical line x equals 2 and the curve y equals e to the x divided by 2 power. We need to find the area of this yellow region. Well, this will be the integral from 0 to 2 of e to the x over 2 dx. I will evaluate this integral by u substitution, but I'm going to do it mentally. In fact, I'm only writing this part down so you can see what I'm thinking. U is x divided by 2, so u prime will be 1/2. Normally, I wouldn't even write that down. We know that the antiderivative of e to the u is still e to the u. But instead of dx, we now have du divided by u prime. So we have to divide by 1/2. Dividing by 1/2 is the same as multiplying by 2. Next, we apply the limits of integration from 0 to 2. This means we need to find the value at 2 minus the value at 0. So I'm going to have 2 times e to the 2 over 2 minus 2 times e to the 0 over 2. 2 divided by 2 is 1, so we have 2 times e minus 2 times, and e to the 0 power is 1. So we just have this. So the answer is A. Let f be the function defined by f of x equals the square root of the absolute value of x minus 2 for all x. Which of the following statements is true? The key to this problem is a nice sketch. Let's start with the parent function f of x equals the square root of x. What does this look like? Well, hopefully you know that this is sort of half of a sideways parabola. Now let's make it the square root of x minus 2. What type of a transformation is this? The x minus 2 is a translation 2 units to the right. Think about why this graph stops at x equals 2. For values of x that are less than 2, for example, what if x was 1? Then I would have 1 minus 2, which would be negative 1. Now I have the square root of a negative number. That's imaginary. So the graph has to stop at 2 because any values of x that are less than 2 will cause a negative number under the radical, unless we put an absolute value in here. Now, even if I use numbers going to the left, they will be positive values under the radical thanks to the absolute value. The end result is I will have the same type of picture that you see on the right mirrored on the left. So the graph looks something like this. We can use this graph to help us answer the question. We need to know which one of these statements is true. Let's start with statement A. F is continuous, but not differentiable at x equals 2. Is f continuous? Yes, it is unbroken, no discontinuities. Is it differentiable at x equals 2? No, there's a cusp at x equals 2, so it is not differentiable, meaning we can't take the derivative. So A is true. And A is the answer. Take a moment to convince yourself that the other options are all false. Using the substitution u equals the square root of x, this definite integral is equal to which of the following? First of all, if u is equal to the square root of x, which is the same thing as x to the 1/2 power, then u prime will equal 1/2 x to the negative 1/2 power. Dropping the x to the negative 1/2 power down to the denominator, we have 1 over 2 times the square root of x. Performing the substitution, we write e to the u over the square root of x, but instead of dx, we write du divided by u prime. So that's du over 1 over 2 radical x. If we multiply straight across, we notice that the radical x and this radical x cancel each other out. This is sort of like radical x over 1, and this is 1 over radical x, so you can see that they will cancel each other out. However, I still have this 1/2 by which I am dividing. Dividing by 1/2 is the same thing as multiplying by 2. So this will become a 2 out in the front. But what about the limits of integration? This 4 is an x value. We need to turn it into a value of u. But we have this little equation right here. U is equal to the square root of x. So if x is 4, then u will be the square root of 4, also known as 2. Similarly, this number 1 is an x value. U will equal the square root of 1, which is 1. So now we see that the answer is C. The function f is defined by this piecewise function. What is the value of the integral from 1 to 5 of f of x dx? Notice that the limits of integration from 1 to 5 pass by this value x equals 3, where the piecewise function changes from the top piece to the bottom piece. Because f of x changes expressions at x equals 3, we need to take our original definite integral from 1 to 5 and rewrite it as two separate definite integrals, the integral from 1 to 3 plus the integral from 3 to 5. On the interval from 1 to 3, f of x is given by 2, because x is less than 3 on this interval. On the interval from 3 to 5, f of x is given by x minus 1, because x is greater than or equal to 3. So we just have to evaluate both of these definite integrals and add them up. The antiderivative of 2 is 2x, and here I have applied the limits of integration. Similarly, the antiderivative of x minus 1 is 1/2 x squared minus x, and here you see the limits of integration. For this first part, we have to find the value at 3 minus the value at 1. And then for the second part, we need the value at 5 minus the value at 3. Doing all of the multiplication and distributing this negative sign gives us this. 6 minus 2 minus 5 plus 3 is 2, and 25 halves minus 9 halves is 16 halves, which is 8. So that gives us 10. So the answer is D. If f of x equals the square root of x squared minus 4, and g of x equals 3x minus 2, then the derivative of f at g of x at x equals 3 is which of these? Here is an expression for the composite function f at g of x. I just took the expression for g of x and I plugged it in for x right here. If you expand the binomial squared by multiplying 3x minus 2 times 3x minus 2, you get this trinomial. Of course, the positive 4 and the negative 4 cancel each other out. So this is our expression for the composite function f at g of x. Now let's take the derivative. As we take the derivative, we will think of the composite function as 9x squared minus 12x to the 1/2 power. Here comes the chain rule. Let's put the 1/2 power in the front, and the new exponent will be negative 1/2 power. Inside, we still have 9x squared minus 12x, but the chain rule demands that we now multiply by the derivative of this inner function. That's going to be 18x minus 12. Now that we have an expression for the derivative of the composite function, all we have to do is evaluate at x equals 3. Substituting 3 for all the x's gives us this. Simplifying the expressions inside the brackets gives us this. 1/2 of 42 is 21, so I will have a 21 in the numerator. The 45 to the negative 1/2 power will show up in the denominator as the square root of 45. Let's simplify the square root of 45. Well, 45 is 9 times 5. So this will simplify down as 3 radical 5. And we still have the 21. Of course, 3 goes into 21 7 times, so we have 7 over the square root of 5. So the answer is A.